So in this video, I'll show you how to make a gun with realistic bullet physics using the FastCast module in Roblox Studio. So this is the first video in a series where I'll be continually adding on to this base gun that you see here. I'll be adding things like reload and bullet holes and just cool gun features, but it's too complex to put in one video. So this just gives you the basics. I can shoot things, I can kill things. I have a bullet part. And of course, I will put the link to this model in the description if you just want to take it, use it as a reference, use it for one of your games. I don't really care. Use it for whatever you would like. Make sure to like and subscribe if you enjoy this video. Without further ado, let's get into it. So I have in front of me a basic model with two parts, a barrel and a grip, and they're both welded together. They both have anchor to false and can collide off as well, just so we can make our tool work nice and well. So first thing I'm going to do is create a part. I'm going to name this part my handle, and this is going to be for basic tools, so we can just get our part working and we can start like programming it. So I'm going to go to my grip, copy the position, and you can obviously do this however you want. I'm just doing a little basic intro to it, so for the people who don't know how to work with tools, they can just follow along. So I have my handle there. Try to make it transparent, just make it easier. Can collide off, and then I'm going to highlight this and my grip. There we go, and go to model, create weld. So the grip, yep, there we go, it's welded, that's good. Now I'm going to go create a tool, put the model and the handle in my tool, and we're going to name this tool gun. Make sure your handle is named handle with a capital H, cannot be named anything else or your tool will not recognize it. Let's drop that in a starter storage, or starter pack. We can see how it looks. So it looks perfectly fine. If yours is messed up, you might have to rotate the handle a little bit, but in my situation, it looks perfectly fine. So one other thing I'm going to do is I'm going to drag my gun back into the workspace, and I want to define a position at which I want the bullets to fire. So I'm going to go into my handle, click the plus, create an attachment. Here's our attachment, and we can just move this attachment. Let me just move it to the very front of the gun to where you would assume the gun would fire out a bullet. So let me just put it right there. That looks about good. And I'm going to name this the fire point. My attachment's going to be named fire point. So I'm going to drag this gun back in a starter pack, and we are good to go. So now we can start scripting. I'm going to go into my toolbox and grab the FastCast Redux module by Eddie the Spirit. If you don't have this, the link will be in the description, but this module will allow us to simulate realistic bullet physics without having to write our own like raycast engine, because this module uses raycasting as opposed to velocity, because velocity is really clunky, it's laggy, and it's very inaccurate with like touched and whatever. So we're going to be using raycasting, specifically the FastCast Redux module. So I'm going to take this module, drag it into my gun, and here we go. So we can first start by creating a local script in our gun, and then create a normal script, because we need both client input and server input. And we also need to add a way to communicate between them. For that, we're going to use a remote event. And I'm going to name this event fire event, name my local script client, and name my server script server, just so it makes a little more sense. So we're going to start in the client script. Let me zoom in. There we go. First variable we're going to define is our tool, which is going to be equal to script.parent. Then I'm going to get my player, which will be equal to game get service players.local player. And the reason we need our player is because we need our mouse. So local mouse equals player get mouse. So I know I made a custom mouse module a few videos ago, but for the simplicity of this video, I'm going to use the built-in Roblox mouse. It's just less dependencies, but feel free to use your own mouse module if you have it, or if you wanted to use mine, I'll put a link in the description for that as well. So now that we have our mouse and our tool, we also need to get our fire event, which will be equal to tool wait for child fire event. And make sure to use wait for child on the client, because with tools, it does take a lot of time to load, so you're not guaranteed to have it. So you might have to wait for it. So now we're going to call tool.activated. We're going to connect a function. So this function will be fired every time the tool is clicked, like you click with the tool in your hand. So when this happens, we want to first get the mouse position, which will be equal to mouse.hit.position. And this is a position in 3D space where you click your mouse. And we want to send our mouse position through our fire event. So we're going to take fire event, fire, server, mouse position. There we go. So now we can go to the server. Let's also get our tool, which will be equal to script.parent. We can get our fire event, which is tool.fire event. You don't really have to use wait for child on this one. And just because we need it later, we can define FastCast equal to require tool.fastCastRedux. So now we can make a function called fire, and this will be called whenever we want to fire the gun. In this function, we'll get the player who wants to fire and also the mouse position in which they are clicking. We can hook up this event to our fire event by saying fire event on server event connect fire. Make sure no parentheses, just fire. There we go. So now, just to test, we can print player.name fired at mouse position. Just a little print statement. I would recommend doing this just to make sure everything works. So we have our gun. We click. Yeah, there's an error, but that's more of a concatenation error. Let me fix that real quick. Instead of concatenating, we'll just use commas. This should work a little better. So you can see it says bricey763, which is my name, fired at a arbitrary position. And you can see as I move my mouse, it's changing. That's exactly what we want. So now we have client-server communication established. So our gun can successfully print things. We want it to fire bullets and damage players, not just print things. So we're going to start by creating a caster. And we're going to create it by saying FastCast.new. So caster is basically FastCast equivalent of creating a new gun, basically. You don't create this every time you fire. You only create this once for your gun. And this allows you to fire bullets and connect events to certain bullet actions. So we have our caster, and we can just fire it by calling caster fire. There we go. And it takes in a few parameters. So let's define those up here just to make it a little more transparent. So we're going to find the origin. This is where the bullet starts, and we're going to set that equal to our fire point, which is our attachment that we have in our handle. So let's just define that up there. Local fire point equals tool.handle.firePoint. There we go. So we can set it to firePoint.world position. Do not do position. Position and attachments is relative. We want the world position of our attachment. And we can get our direction, which will be equal to mouse position minus the origin dot unit. Is basically saying we get the vector between our fire point and our mouse position, so it's accurate, but it also starts at the right spot. And we get the unit vector, which basically turns it into a magnitude less than 1, which is good for directions. So now we can fire our caster with the origin, the direction, and then a velocity value. So for our velocity, you can set this to a number or a vector 3. I'm just going to set it to a number, and we're going to say 10, for example. So if we were to run this right now, nothing would happen when we fire it because there's no way to visualize our firing. So FastCast has a handy feature where we can say FastCast.visualizeCast equal to true. This is just good for debugging when you don't have a bullet. We will make a bullet and a bullet part a little bit later, but for now, this will do the trick. So we're firing a imaginary like ray with origin here, direction here, with a velocity of 10. So let's just play this, and we can see what happens. So we click, and you can see the bullet is represented by this little trail of black lines, and when it hits, it has a little green sphere. This is really good for testing your guns. You can see it starts at our tip, and it goes directly to our mouse position. So if I don't move my mouse, you can see it goes spot on, which is exactly what we want, and that's great. So right now we can fire our gun with a little bit of velocity, but you can do a lot more in FastCast, and the easiest way to do that is by using a cast behavior object, and we can make that by calling FastCast.new behavior. And there's a few parameters or properties in our cast behavior that we can change. A notable one is cast behavior dot acceleration, and we can set this to a vector3.new. So for example, vector3.new. So for example, if we wanted to add gravity, we can say negative workspace dot gravity for the Y. So it's basically pulling our part down. It's accelerating our part towards the ground, just like how normal gravity does. We can also define a cast params object, which will be a raycast params dot new. If you don't know about raycast params, I touched on it in my new raycasting video, so you can check that out for it. And we can say cast params dot filter type equals enum dot raycast filter type dot blacklist. This is basically saying for all of our filter descendant instances, we want to ignore them. We don't want to hit them. So we're also going to set our ignore water to true, because this is a gun. It should be able to go through water. So now we need to set our filter descendants instances. Now, the way we're going to do that is going to be quite interesting. We're going to define a function, local function on equipped. This is for our tool. So every time the tool is equipped, we want to set the cast params dot filter descendants instances equal to a new list with the curly brackets. We want to set this to tool dot parent, and then our bullets folder, which we'll define a little bit later. So let's leave this for now. Set it to tool dot parent. So every time we equip our tool, we want to set our ignore list to our characters, because you just shouldn't be able to hit your own character. That'd be stupid. You want to ignore it. That won't do anything until we go down here and we hook it up to a tool.equipped connect on equipped. There we go. Since we're doing that, we want to set cast behavior dot auto ignore container to false, because that's redundant. We're already doing that down here. We're auto ignoring our tool's parent. The tool is a container, so the parent descendant is a tool, so we're automatically ignoring it. We don't really need that. And now to bring it all together, we can set our cast behavior dot raycast params equal to the cast params. That won't do anything until we send it into our fourth argument for the cast or fire. So we can say cast behavior. There we go. So right now, we can play this. And you can see the bullet just falls, because that's how it's accelerating. And if we shoot into ourself, it also falls through our body, which is exactly what we want. So that's perfect. So now let's visualize our bullet in a prettier way using actual bullets. So the first thing I want to do, I'm going to go to the very top, define a bullets folder, and we're just going to make a new folder. I could, using instance.new folder, I could create this folder in the workspace and then reference it, but I want this gun to be standalone, meaning it has no external dependencies in your project. So I could upload this to the toolbox and then you can paste it into your own game and you can use it out of the box. So we're going to create a new folder, or we can also check for workspace, find first child bullet folder. So this basically is saying that we create a new folder. Actually, we should reorder this. My bad. So this should be first. So we check, and then if there's no folder, we create a new folder, and then we can do comma workspace, which basically says if there's no folder already in the workspace, you could create a bullet folder. Actually, I'll do that. I'll create a bullet folder and call this bullet folder in the workspace. If it's not there, then we create a new bullet folder. And for the new folder, we can just call bullet folder.name equals bullet folder. There we go. So now we have a bullets folder. My bad. So now we have our bullets folder created. And we want to do a few things with this. Firstly, we want to go to our onEquipped function and add our bullets folder here. So it ignores other bullets as well, which is what we want. And then into our cast behavior, we want to say cast behavior dot cosmetic bullet container equals bullets folder. So now we can actually create our bullet. I'll do this right below our bullet folder. Local bullet template equals instance.new part bullet template dot anchored equals true. Bullet template dot can collide equals false. And let me just set the shape to a ball. You could set this to whatever you want. And no, right now with this version of the gun, you can't really use models. These models would just be too laggy and it just wouldn't work well. So you could use a union if you wanted to and like define it in server storage and then reference it. But again, I want this to be standalone, so I'm just going to make my bullet inside the code. I said the bullet template dot size. We're going to make this pretty big initially just so you can see it. We're going to set this to 1, 1, and 1. And we can set our bullet template dot material equal to enum dot material dot not neon. Let's do some metal since it's a metal bullet. So that bullet should work quite well. In our cast behavior, we can say cast behavior dot cosmetic bullet template equals our bullet template. There we go. So that creates a new bullet when we fire our gun, but it does nothing. So in order to actually register our bullet and put it where we want to, we need to make a new function. Local function on length changed. And this function will take in a few parameters. So the first parameter is the active cast. We don't really have to worry about that. We won't deal with that. It's just like a table with some info pertaining to our active raycast. And next is our last point, which is a vector. We have our direction. Then we have our length of our segment, our velocity, and finally the bullet. I spelled velocity wrong. Let me fix that. Velocity. So first we want to make sure our bullet exists because Roblox is a chaotic world and we don't want to be changing our bullet if it's not there. Then we can define our bullet length, which will be equal to bullet.size.z divided by 2. And we can set our offset, which will be equal to cframe.new 0, 0, and then negative parentheses length minus bullet length. So this length variable is the length of the segment of our raycast, because FastCast, you see those little cones when we're visualizing our cast, that's each segment of our raycast or FastCast. So we want to offset our bullet so it doesn't go past each segment. So when it hits a wall, for example, it doesn't phase through the wall. We want to keep it behind the wall. It looks better and it just functions better. So that's what we're going to do. And we can now set our bullet.cframe equal to cframe.look at last point, then last point plus direction. And then we're going to say to world space offset. So what this does, let me just, I spelled direction wrong as well. So what this does is we take our last point, then we look towards the direction that we're going by adding it to our last point. And then we're adding a offset, C-frame offset, relative to this C-frame by using to world space, so it is on the right place in regards to the local z-axis. So this on-length change will run every single time the array is updated. So I'm going to go to the bottom of our script, and I'm going to say caster.length changed connect on length change. So this connects our length change function to the actual event part of our caster object. So let's test it out. And I'm going to turn off visualize cast by just commenting it out, because it's off by default. And you can see that our ball shoots and it falls and it stops and it looks nice, and you can see it does not collide with the floor. You could obviously make it do that if you wanted to, but this just looks a little cleaner. And I think it's time we go and we ramp up our velocity. So I'm going to go find our starting velocity, which is all the way down here. Set this like 1,000, and this will get you more of a gun realistic physics. So my gun, you can see it's pretty quick, but you can also see there's travel time, and if I were to go into first person and I shoot, the bullet goes a little bit below my mouse. So now we're getting into a gun that actually works as intended and has bullet drop and bullet travel time. So there's one last thing to do. Right now, our gun doesn't do anything when it hits another player. We need to change that. We want to do damage. So I'm going to define another function below length change, and we're going to call this local function on ray hit. This will be called whenever our ray collides with the ground and it stops updating. So we get the cast object once again. This is the ray cast result, and we have the velocity and the bullet. There we go. So I can define my hit equal to result.instance. So the hit and the result.instance is never nil. I don't know how. I don't look at the back end of FastCast, but it's never nil. So it's safe defining it here. It won't error. But we want to make sure the hit actually exists as a character, or like part of a character. So we can say local character equals hit find first ancestor, which is a model. So this will find the model that's part of your character, and we need to check if the character exists, if it's parented to a model, and the character has a humanoid, which we can do by saying character find first child humanoid. Then we can say character dot humanoid take damage 50. So when we hit a player, we'll give them 50 damage. And since we're dealing with guns, we're dealing with bullets, we want to make sure to recycle our bullets. We don't want them staying on the ground forever. So we're going to use the debris service. Game get service debris. And we're going to add item bullet. Let's just do 2 seconds. So after 2 seconds, our bullet will get destroyed. That's what this add item of the debris service does. So now we can go to the very bottom, set caster dot on, or not on, we would just say caster dot ray hit connect on ray hit. There we go. This will update whenever we hit something. You can see I put down a few zombies to test this out off camera. You can see when I shoot them, the bullets stay. You can change how long the bullets stay. It's just for demonstration. But you can see the bullets hit them and they do damage, which is exactly what we want. And that's about it for this video. So thanks for watching. This just scratched the surface of what you can do with FastCast and just making a gun in general in Roblox. So in future videos, I'll be covering part cache, which allows you to make more efficient bullets, bullet holes, ammo and reloads, maybe a debalance in there, like for the reload, like a cooldown, maybe a fully automatic gun, or even different types of guns, like a shotgun, a bow and arrow, or a rocket launcher. So if you're interested in any of that, make sure to comment down below. Other than that, I hope you have a nice day, and goodbye.